Okay guys, today we're doing 4.4 critical numbers, or we can think of them as horizontal and vertical tangent lines. Okay, both of these horizontal and vertical tangent lines are both critical numbers. Let's get started. How do we get started? Okay, here we go. Warm up 2. Okay, I just warm up 1. So let's get started here. Having problems. Okay, here we go. Okay, first we're going to talk about this graph. Okay, first off, I should tell you guys all of these are primes. They're difficult to see on there, but those are commas. Those are apostrophes. Okay, now this is a graph of the original f of x, not the derivative. Okay, so what we're going to talk about is where is the function f of x, where is the derivative greater than 0? Okay, now let's first define what this means here. Because mathematically, maybe it looks like nonsense. But if I change what it says, okay, what does derivative mean? Derivative means slope, right? And it's saying when is the slope greater than 0? Another way of saying greater than 0 is when is the slope positive? Okay, so that's another way of thinking when is the derivative greater than 0? When is the slope positive? So that's easier to think about here. So let's just talk about it in terms of intervals of these letters here. E to A, the slope is negative, right? It's going down. A to B, the slope is positive. So we can say from A to B. Where else is it? Okay, B to C, no. C to D, no. D to F, D to F is definitely true. Okay, and then last one here, F to G, it's also increasing. So let's call F to G true as well. That is where the slope is positive. And we're going to be using inclusion brackets on all of these, okay, for the Cal 1 test. Okay, where is the slope? Negative, the first derivative less than 0. That means slope negative. Okay, well, that would be from E to A. Okay, let's also B to C and C to D. So let's just say that entire time B to D, B to D. And then D to F is positive and F to G is positive as well. So we can stop there. Okay, now where is the slope, the derivative, equal to 0? So when is the slope 0? Or another way to think about it, when is the slope horizontal? Yeah? So this could be slope horizontal. Okay, and let's just look through here. Okay, the slope is not horizontal anywhere in here. It's always negative. Then it just immediately switches to positive. And then notice right here, the slope evens out, where it switches from increasing to decreasing. You have to have a slope of 0 because you went from positives to negatives, right? In order to go from positive to negatives, you have to go through 0. So this right here is a horizontal slope. So we're going to say that the derivative is equal to 0 at B. Let's see if there's any other point where this happens. It's going negative, 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 and switches to positive. Okay, so right here, whoa, that is not a horizontal slope I drew. But right there, it has a horizontal slope as well. So we can say B and D. Anywhere else? No, there is nowhere else where that occurs. Okay, notice this is a max and this is a min. That's something we'll be talking about in the future. These places where the derivative is equal to 0, you could have a max or a min. Okay, where is f prime undefined? Okay, so that's going to be talking about when is there no slope, or when is the slope undefined. Okay, let's walk through here. Okay, so you have a negative slope, and it immediately switches to a positive slope. So right here at A, if I was to ask you what is the slope, you don't know if I'm talking about the slope on the left or the slope on the right. The slope's undefined right here. You don't know what the slope is. So when is the slope undefined? At A. See if there's anywhere else. Okay, positive slopes, a 0 slope. Negative slopes, a 0 slope. Positive slopes, positive slopes. Right here, there's an up and down slope. Now, if I was to say, what is the value of that up and down slope? You would have to say, well, it's rise over run, right? Well, the rise would be infinite divided by the run being 0. So you can't define what this slope is because it's just straight up and down. It's undefined. So a vertical slope counts as an undefined slope, and that happened at G. Okay, so those are all the undefined slopes, places where you have a sharp turn and places where it's up and down. Okay, so where's the slope undefined? Anywhere where there's a sharp turn or vertical. Okay, next thing here, where are there critical numbers? Okay, critical numbers is what we're talking about today. Critical number is where the derivative is either equal to 0 or where the derivative is undefined. Now, if you notice, those are the last two things we did here. So a critical number occurs at B, D, A, and G. Those are all critical numbers. Okay, right there, right there, right there, and right there. Those are critical numbers. So what you probably should write down is critical numbers. Critical numbers, and we're gonna circle all of this. A critical number is when you have a horizontal, now what we call this, the derivative is equal to 0. I'm sorry, this one, the derivative is equal to 0. We call that a horizontal tangent line. I said the slope is horizontal, right? So we're going to say horizontal tangent line, HTL, when the derivative is equal to 0. That's a critical number. That's one type of critical number. The other one is when there's a vertical tangent line, or an undefined slope, where f prime is undefined. Okay, those are critical numbers. There's two types of them. Okay, let's go forward. Okay, is there a horizontal or vertical tangent line at any point on this graph, and what type of graph is it? Okay, so let's just look at each one of these, and we can tell me if there is a horizontal or a vertical tangent line anywhere. And on this one, there is a horizontal tangent line. It's right here at the max. This is a graph, it's a parabola, it's a negative x squared, right? Okay, let's go forward. Let's try some more of these. Okay, is there a vertical or horizontal tangent line there? And yeah, there is two horizontal tangent lines. There's one right here and one right here. And this looks as though it's probably a sine function. Yeah? Let's go forward. Okay, is there any horizontal or vertical tangent lines here? There are no horizontal tangent lines. There's nowhere where the slope is 0. Like if you follow this, the slope's always positive, right? So there's nowhere where the slope is 0. But there is a point where the slope is undefined. Right here, there is no slope. So we're going to call all these places where there's vertical asymptotes, those are undefined slopes. Those are vertical tangent lines. Okay, so all those are vertical tangent lines. Okay, let's go to the next one. Okay, is there a horizontal or vertical tangent line here? Yeah, there are horizontal tangent lines right here, and right here. That's where all the slopes are 0. And you have vertical tangent lines as well on this. And that was where all the vertical asymptotes were. Sorry, my thing got stuck, my little cursor. Okay, are there horizontal or vertical tangent lines here? And yes, there are. There's a vertical tangent line right here where the slope is undefined. Okay, there's a vertical asymptote. That's a vertical tangent line. Now, horizontal tangent line, this thing actually never has a slope of 0. It goes very far back there, and it gets very close to this value of 1, but it never actually flattens out and has a slope of 0. It just gets to be a smaller and smaller slope, approaching a slope of 0, but it never actually has a slope of 0. So here there's only a vertical tangent line. And it occurs at x equals 1. That's an x. Okay, let's go through, let's do some problems here. So find where the function below has a tangent line with a slope of 0, or what we call a horizontal tangent line. Okay, so what we're trying to find out is when it has a slope of 0. We can call that a horizontal tangent line, HTL. In order to do that, first we should probably look at the slope. In order to look at the slope of this, slope means derivative, so we need to take the derivative. The derivative of g, that's going to be 3x squared minus, this 2 comes over here and only multiplies with the 5, 10 over 2x minus 2, and the derivative of 12 is nothing. So our derivative is going to be 3x squared minus 5x minus 2. 10 divided by 2 is 5, right? Okay, now we're trying to find out when the slope. This is an equation to find slopes, because it's the derivative, when it has a slope of 0. So that means we're going to be not plugging in 0, because if we plug in 0, that tells us what the slope is at 0. We're actually going to set it equal to 0. That's going to tell us when it has a slope of 0. Okay, well, on this one, in order to solve that out, we're going to have to factor. So 0 equals, we have our two factors here, 3x and x. I don't know how you like to factor, but let me show you my method here. I put 3x and x here. These are going to be my two factors, okay? If you're confused on this, these are my two factors. And we're just going to take a guess method here. We're going to look at all the multiples of 2, which are only 2 and 1. And then we're either going to put them as 2 on top and 1 on bottom, or 1 on top and 2 on bottom. So let's see what happens here. Let's do 2 and 1. And you're just going to cross multiply here. 3 times 1 is 3x. X times 2 is 2x. And can we make this middle portion of negative 5 with that? Yes, we can. We can make both of them negative, right? That would make negative 5 in the middle. That would make both of these negative. And then just to double check, to make sure you got the correct answer, just multiply these two things, negative 2 and negative 1, and it should make this one. But as you notice, negative 2 times negative 1 make positive 2, which is not negative 2. So this does not work. We cannot use this. Let's switch it so we have the 2 on bottom and the 1 on top. Okay, 3 times 2 is going to be 6x. 6x, and x times 1 is going to be 1x. Can we make that middle number? Yeah, we can. We can make this a negative and this a positive. Okay, so the negative went with the 6, so we're going to have minus 2, and the positive one with the 1. And let's multiply these two numbers here just to make sure it makes that end number. 1 times negative 2 is negative 2. Okay, we're good. So our factors are 3x plus 1 and x minus 2. And we just set each one of them equal to 0. Oh, x minus 2 equals 0. Okay, this is going to give us 3x equals negative 1, x equals negative 1/3. This one gives us x equals 2. Okay, those are my two places where I have horizontal tangent lines. Okay, so if you were to graph this, thing, you would see that it switched from increasing or decreasing, or vice versa, at these 2 points. Okay, it has horizontal tangent lines, slopes of 0 at those 2 points. Okay, let's do another one. Find where the points of this have critical numbers on the interval 0 to 2 pi. Okay, critical numbers. That's the key word on this one. Critical numbers. That means horizontal tangent lines or vertical tangent lines. Okay? Now, that means that we're going to have to take the derivative. Let's take the derivative of this thing. The derivative of x is going to be 1. The derivative of sine is going to be cosine. And we're going to have to set it equal to 0. That's what this means. Horizontal and vertical tangent lines means we set it equal to 0. 1 plus cosine of x. Subtract the 1 over, so we get negative 1 equals cosine of x. And you just need to know, when does cosine equal negative 1? And what I would do to figure that out is I would set up my unit circle. And right here, when you have an angle of 0, you have sine, or the y value, equals 0, and cosine, or the x value, equals 1. Cosine equals 1. Okay, and then at this point up here, you have sine value equals 1, and cosine equals 0. That's the x value, right? Then over here, you have sine value equals 0 again. Cosine value equals negative 1. over here you have sine value equals, sine value equals -1 and cosine equals 0. And it just keeps flipping around like that, right? And this is at an angle of 0. This is at an angle of pi over 2. This is at an angle of pi. And this is at an angle of 3 pi over 2. So when does cosine equal -1? At pi. So x is equal to pi. And there's a whole bunch of places. I mean, you could have gone backwards. So it could occur. Now I'm only looking at the interval 0 to pi. That's the only place it occurs from 0 to 2 pi. 2 pi reevaluates right here, right, at 0. That's the only place where cosine equals -1 on that interval. Now, if you were to go beyond the interval, it also occurs at 3 pi, at 5 pi, at 7 pi. Or if you go backwards, it occurs at -pi, at -3 pi, at -5 pi. It just keeps on occurring like that. Now, I do have a graph of this one, so you can see it. We said that it has a horizontal tangent line or a slope of 0 at pi. Check out this graph. Now pi, remember pi is 3.14, which would be somewhere around here. And if you look at it, it has a slope of 0, a flat slope. Yeah? So it doesn't necessarily mean that the graph has to go from increasing to decreasing. The graph could go from increasing to increasing. Yeah, like this one does. It increases and then it switches back to increasing. But it had a slope of 0 some point in there. And that's what we found right now. Okay, so that is your only answer from the interval from 0 to 2 pi. Okay, I got one more for you guys. Find the x-coordinates where, and I outlined x-coordinates where the horizontal and vertical tangent lines are on the function below, okay? Let's just start this out. Now it wants to know where there's horizontal and vertical tangent lines. That automatically means take the derivative, set it equal to 0. So if you're taking the derivative of this, notice it's going to be implicit differentiation. Right here we got product rule. So I will first just rewrite my first thing and take the derivative of this one. The derivative of y is going to be 1. Since we're taking the derivative of y, we need to put dy over dx. Okay, now, since it's product rule, plus, rewrite the other one, y, take the derivative of this one, which is 6x. And we don't need to write any dy or dx over here because we didn't take the derivative of y. So we're done with product rule. We're done with the derivative of this term. Let's go to the next term. The derivative of this is just going to be 1. And the derivative of 10 is 0. Okay, now all we need to do is solve for dy over dx, and we are solved for the derivative. And in order to solve for the vertical and horizontal tangent lines, we can set it equal to 0. So let's subtract both of these things over so we can isolate the term with the dy over dx. So 3x squared dy over dx equals, now I'm subtracting this over, so I'm going to have negative 6xy. Now notice I reordered this, that doesn't matter. I'm going to add the 1 over. Okay, now I need to solve for dy over dx, so I need to divide by the 3x squared, and I got my derivative. So we got negative 6xy plus 1 all over 3x squared. Okay, this is my derivative. Now I want to find the horizontal and vertical tangent lines. Now, here's something I haven't shown you yet. The horizontal tangent lines. You set the top equal to 0. That finds, saying this equal to 0, that finds your horizontal tangent lines, okay? That's what we've been doing. All the things we've solved on the previous slides, if you look at them, they all only had a numerator. We set it equal to 0, and those were horizontal tangent lines. If you have a denominator, what can you never do? You can never divide by 0. So we're going to also set the denominator equal to 0. That's going to tell us where it's undefined, where the slope is undefined because it's dividing by 0. So this one in this case is very easy. 3x squared equals 0. You can divide by 3, you get x squared equals 0. Square root, the square root of 0 is 0. Okay, if you plug in 0 into this function of the derivative, you would get division by 0, which is an undefined slope, which we call a vertical tangent line. So there's one vertical tangent line. Now the horizontal tangent line on this one is a little more difficult. Let's solve it. We're going to have negative 6xy plus 1 equals 0. Now here's why it's difficult. I told you to solve for the x coordinate, right? If you solve for x right now, you're going to have the answer in terms of y. That answer is going to have a y in it. But I don't want it to have a y in it. I want it to be a number. So what you're going to do is, instead of solving for x, we're going to solve for y. And then we can plug that into the y here, and we can solve for x. So let's just get underway here. Let's solve for y. I'm going to subtract the 1 over. Okay. Then I'm going to divide by the negative 6 and the x. So y is equal to negative 1 over negative 6x, which is the same as 1 over 6x. Okay. Y is equal to negative 1 over 6x. 1 over 6x. This was what y is. I can go over here and I can plug in 1 over 6x right there where y is. And then this entire thing is based off of only x values. And we can solve for the x value. And we'll know the x coordinate for where there's a horizontal tangent line. So we got 3x squared times 1 over 6x minus x equals 10. Now it looks difficult. It's very easy. The x squared and the x can cancel out. So we only have one x on top. Yeah? The 3 and the 6 division, here, I'll just rewrite it at that point. 3x over 6 minus x equals 10. Yeah, because the x squared and the x canceled, leaving us with just an x on top. This can be rewritten as x over 2, because 3 divided by 6 is a half, minus x equals 10. Okay, well, these are like terms because they have the same exponent, right? Well, let's make it so they have the common denominator. I can put it together. So we got 1 minus 2, which is going to be negative 1x over 2 equals 10. We can multiply by 2, and here I'll bring this up here. So we get negative x, negative 1x equals 2 times 10 is 20, and x is equal to, divide that negative over, negative 20. And that's where the horizontal tangent line was. Now notice, we just set the top equal to 0, and we tried to solve for x, but x would have been in terms of y. So we solved for y instead, so we could then plug it into here and get the x value. Now I don't think they're going to do that to you on the test, but they might. I have seen them do it in the past. And that's it.